I want us to discuss something about nature of roots in mathematics. So grade 11 and grade 12, this is for you. Here is a question that I will direct you guys. It's your question on mathematics. It's actually the last question, so it requires you to actually know the following knowledge about nature of roots. So I want first to explain what are roots. Roots in mathematics, guys, are your x-intercepts. So we'll be referring to x-intercepts as the nature of roots. So let's talk about what is nature. So the nature of roots. So it is the nature is the way something is when we come to mathematics. I'm not sure if it's applicable to other contents, but when we come to mathematics, it's the way something is. So when we are talking about the nature of roots, we are talking about the way the x-intercepts are. So I want to first make an example. We'll have a picture. For instance, if you had x squared minus 25 equates to 0, and you were asked for your x-intercepts, whether to solve them or give your x-intercepts. So you have to factorize there, whether using the quadratic formula, but I'm just going to write the factors, which are x plus 5 and x minus 5, because that is the difference of two squares. So you'd have your solution as x equating to minus 5 or your x equating to your positive 5. So guys, if I were to ask you what is the nature of those x-intercepts, or rather your nature of those roots, so you could say that minus 5 and positive 5 are both real numbers, guys. They are real numbers because they are numbers that exist on your number line. What else would you tell me about the nature of roots? You'd see that those roots are unequal. They are unequal. Positive 5 and negative 5 are two different things. They are definitely not equal. What else could you tell me about the nature of those roots? That they are rational, guys. Rational to mean that they can be written in the form of A over B, where B is actually not equal to 0. So those roots are real numbers, they are unequal, and they are also rational. So I'm going to introduce a way which we are supposed to use. There is a way we can predict about the nature of those roots, whether to tell that they are real numbers or non-real numbers, are they rational or irrational. So there is a method we use. Specifically in this question, you'll be required to apply that method. In this method, I want us to write the quadratic formula, which is x into minus b plus or minus b squared minus 4ac divided by 2a. So there is a part in that equation that can be used to predict the nature of roots, which is actually this part inside the bracket, which is called the discriminant, or rather delta. Did I say discriminant? Yes, it is the discriminant. So it is written as b squared minus 4ac. If you can calculate delta, guys, you can predict whether your roots are real, your roots are non-real, or they are equal or what. So these are the following you will need to know about a discriminant. First, if your discriminant, guys, equates to 0, what will you be having there? You'll be having equal roots. Equal roots to mean you'll be having two x-intercepts that will be equal. You'll be having real roots to mean that your x-intercepts will really be there for your function, for your quadratic function. You will have actually real x-intercepts, and they will also be rational, guys. Rational to mean they can be written in the form of a over b or in a recurring decimal. For instance, you have 1 comma 1 1 1 1 up to whatever 1 comma 1 2 1 2 1 2, but irrational would be maybe 1 comma 1 2 3 4 5, but there's nothing recurring after the comma. So that's what I mean about rational and irrational. So first we say when the discriminant equates to 0, you'll be having equal, real, and rational roots. Coming to the second one, when the discriminant actually is less than 0. When you are having a discriminant less than 0, you'll be having your non-real roots, guys. Your non-real roots. So for a function where you calculate a discriminant and it becomes something negative or something less than 0, if you were to draw that function, guys, remember we are talking about a quadratic function or a parabola, so we will not actually have what your x-intercept. It would look like something like this. Yes, it is visible. It would look like something this if your a was greater than 0. So you'd be having a function with no x-intercept, or it would be something like that. So if you can say from that function, I'm having no x-intercept. So that is why you are saying you'll be having non-real roots. There is actually no x-intercept there. I'm hoping you got that. So let me go back to the first one. When your delta is equal to 0, if you were to draw a graph for that, remember we said your roots have to be equal, have to be real, and have to be rational. So what you will see there is actually you'll be having your graph touching the x-intercept twice at one point. It's that case when you'll be having, for instance, x equates to 3 or x equates to 3 if you were to solve the roots or the x-intercept. So it would be something like this. In this case, it will always be that when we are talking about a parabola, your turning point will always be the same as your x-intercept, guys. Coming to the third one, when your discriminant is actually greater than 0. Remember, we said your discriminant, you have to identify what your b is, what your a is, what your c is. So it will always be that equation in that form, ax squared plus bx plus c equates to 0. Before you extract, guys, the values of a, of b, and c, you always have to write your equation in that form, in that standard equation. Or else, if you are having another thing on the right hand side, you will not be able to carefully extract your a, b, and c values. So please, I hope you got that. First, have 0 on the right hand side. You have to make sure of that. So let's come to the case where we are having delta being actually greater than 0. So there you actually be having your real roots, guys. Your roots will be real because it is something greater than 0. So in a graph, we will have a function where you are actually having x-intercept, but will be we are also saying your roots will be unequal, guys. You will not be having your x-intercept as x equates to 3 or x equates to 3, but you will have two different x values. For instance, in this case, your x will be minus 5 or your x will be equal to 5. Those are unequal roots. Then it comes when we take this further, because we may have either rational or irrational roots. So I'm just going to erase this. Let's make some space. In which case we will find your roots as a rational. You will have your rational roots when you are having your delta actually being a perfect square, guys. A perfect square. So when you are having a perfect square, your roots will be rational. Unlike when you are having a non-perfect square. When you are having a number which is a non-perfect square, your roots will be irrational. So what I'm going to do now is try to make an example of each, and at the end of this video we'll try to look at the questioning style as to how they are questioned. These questions are questioned in your NCS examinations. So I'm just going to go through this one. We said the delta, which is the squared minus 4ac, after you substitute substituted the value of b of a and c and got the actual value. So if it is greater than 0, you will know that in the end you will have roots that are actually real, that is your function will have real x-intercepts. You will also be able to deduce that your roots or rather your x-intercepts will be unequal. Then it goes further to subdivide. When you have your delta being a perfect square, your roots will be rational. That is, they can be written in the form of a fraction or a recurring decimal. But when your delta becomes a non-perfect square, which is greater than 0, you will be having your irrational roots, guys. I hope you got that. So let's come first to this one where you are saying your delta equates to 0. We'll come to this example that I've started with as to how we could predict how our roots were going to be real numbers, were going to be unequal, were going to be rational. So I'm just going to erase to make some space here. So let's come when your delta equates to 0, guys. I'm not sure if I can make an example, but let's start from the example we started with. We are saying you are having a function there where y equates to, or rather, f of x, because this is for grade 11 and grade 12, your f of x equates to x squared minus 25, guys. So we want to come to a way how we're going to predict if those roots will be real, unequal, and rational. Remember, we said we first have to calculate the delta, which is b squared minus 4ac, and definitely we have to make one side be equal to 0. That is, you'll remember this easily because when you are trying to solve for your x-intercept, you always make your y to be 0. So let's say I'm having 0 equals to x squared minus 25. So let's take what is our value of a from that equation. Our a is 1. What is the value of our b? Remember, the b has to be the coefficient of the x. We are not having an x, so our b is 0, and our c has to be minus 25, guys. So let's come to the actual calculation of what is our delta in this case. So our b is 0 squared minus 4 into what is our a? It's 1. What is our c? It's minus 25. So if you could work this out, I'm sure you'll come up with an answer of positive 100. So let's come to what we talked about here. We said when our delta is greater than 0, this time our delta is 100, and 100 is actually greater than 0. So from that you have to deduce that your roots are what? Are real, guys, because your delta is greater than 100. And you also have to deduce that your roots are unequal. You're going to have to memorize this, guys, because there is no way I can give you to remember it. But I'm just going to write the mnemonics on that side. I can help you to remember it. So now we want to determine if whether these roots are rational or irrational, guys. What you actually have to do is take your value of delta, and put it under a square root, because you have to determine if whether the delta you are having is a perfect square or a non-perfect square. So if you were to put that 100 under a square root, I'm sure you get an answer of 10. So 10 can be written as 10 over 1. So that 10 is the what? Is the rational number. So you'll be able to deduce lastly that the roots are actually rational. Remember, what are the roots? I did not ask you to solve the roots, but we did earlier. We had the root of x equates to minus 5, or the second one was 5. These both are real roots. They are unequal. It's minus 5 and positive 5. They are also rational. It's minus 5 over 1 and 5 over 1. That is how you are going to predict, guys. So let's come to another example where we predict the nature of roots. I'm just going to make an example. I'm not showing if it will work out, but I just want you guys to get the basic idea of how to predict. Let's say this time our f of x equates to x squared minus 24, guys. So, okay, first we say we have to get 0, x squared minus, let's say 25, I try to say 24, guys, 24 because we'll only be repeating our previous example. So let's calculate delta from that. Our delta equals to b squared minus 4ac. So I'm going to substitute, still our b is 0, our a is 1, and our c is minus 24, guys. So I think you could work out that you, in the end, will be having, I'm still writing this 25 clearly and liking that number 25. So in the end, you'll be having something like positive 96, if I'm not mistaken. I'm not using a calculator, but it's something close there. So you are having a discriminant equating to 96. From that, you deduce that when you are having your delta being greater than 0, you'll be having real roots. So you can see if you were to calculate the x and the z, they actually work out, you actually come with an answer. So what else can you deduce? You deduce that your roots will be unequal. And then the last part to determine if whether they are rational or irrational, take that 96 and put it under a square root. I actually don't have a calculator, but from what I know is that 96 is actually not a perfect square. So if you pass that, it will give you something like a set or something that cannot be written in a form of a fraction. So you deduce that your roots are actually irrational in this case. So that is how you predict, guys. Coming to the mnemonics, I want us to know the mnemonics about when delta is greater than 0. So we would say that we are having real roots and equal roots, and when we are dealing with a perfect square, we have rational roots. So I don't know how we are going to pronounce that, but it's R-U-R. You can put it on your mind. I don't know how. Another mnemonic. What if we wanted to have a mnemonic when we are having delta equating to 0 and we are having a non-perfect square? You have to say, okay, I'll be having real roots, unequal roots, and actually irrational roots. So that is R-U-I. You are going to pronounce it as how you like. That is a mnemonic. So when you are having your delta being actually less than 0, you don't have to say much that you are having non-real roots. When you are having non-real roots, they don't matter if they are rational or irrational because they are actually non-real. When you are drawing a function, you are not going to have your x intercept. Let's come to when delta equates to 0. We are saying we will be having real roots, we will be having equal roots, we will be having rational roots. So there you have it, it's rare. I actually pronounced it, actually I do not want to do that, but you can pronounce it as rare. So these things are going to help you remember the nature of roots. So I'm actually going to come to an example, the way you are going to be asked. I'm not going to make further example, guys, because you can see the calculation of delta, you substitute in that equation. So in the instance where you have calculated the delta being -2, you know that those are what? Those are non-real roots. In the instance where you had to calculate your delta being equal to 0, you have to know those are real, equal, and rational roots. So I'm just going to put the way you are going to be questioned in grade 11 and grade 12. So say for instance we are given an equation saying x equates to -6 plus or minus into 12 minus, let's say 8 then, or rather let's say 3a, let's divide it by 2. So in the question you may be given that expression and you are asked what would be the value of a. You can give the x. I actually spoke also. What would the values of a be if the roots of that equation were equal? I'm going to repeat the question. What would the values of A, or determine the values of A for which that equation has a real roots? So what you have to focus on is that delta, guys, because it is the one that determines which nature of roots we are going to be having. So there, I told you guys that you know that b squared minus 4ac from under that root, guys, that square root. So what is already in there is your delta. It's not always the case that you are going to calculate the delta yourself. For instance, this time you are given your delta as what? As 12 minus 3. How did I know that it's 12 minus 3a from my quadratic equation? I know that inside the brackets I find my discriminant. So the question was saying for which values of a would that equation have real roots? Sorry, equal roots. What do you know about delta when you are having equal roots? You know that your delta has to what? Equate to 0. So what you'd have to do is equate that 0 from that equation 1. I'm going to plug the right hand side. It says 12 minus 3a, and then from there I'm just going to solve by a. So I'd be having 3a equating to 12, dividing both sides by 3 would actually give me 4. Now let's change the question. We are going to play that one. Let's say what would or determine the values of a for which the equation above has non-real roots. So when I'm having non-real roots, I know that my delta has to what? Has to be less than 0. So what is your delta? It's 12 minus 3a. I'm plugging that 12 minus 3a less than 0. And I'm solving for a. How do I solve for a? I transpose the minus 3a to the right hand side so that I'm having positive 3a, dividing both sides by 3a. I'd be having my a greater than 4. So that is how we are going to be questioned. But there was a problem I'm specifically interested in when they say determine the value of a for which the roots of that equation will be real. That sometimes puzzles other learners, but it's not actually something you can get fast over. When they are saying real, remember that we mentioned the real in two places. We talked about real roots when we said our delta is equal to 0, and we also talked about real roots when we said our delta was greater than 0. Remember? They are real, they are both real, yes. So what do you actually have to do when you are faced with that case? You don't know whether you are going to plug delta equates to 0 or delta is greater than 0 because they only said real, guys. So you have to combine the two. You have to combine equal and greater than. How do you combine that? You have to say delta equate is greater or equal to 0, guys. So from there, I'd have to say my 12 minus 3a is greater or equal to 0. It's because of, guys, they said real, and you know we are getting real roots in two cases. That is in case 1 when your delta equates to 0 and we are having equal, real, and rational. And in case 2, we are having a delta greater than 0, we are having real, unequal, and either rational or irrational roots. What else did I want to talk about? I think that's all, guys, for this video. I wanted to share this with you because many people may find difficulties. This question is specifically found where at the end of question 1, if it is questioned, it will always be the end of question 1. It is also questioned in the nature, in cubic functions. We'll talk about it when we get there in cubic functions as how these roots or the nature of roots are questioned. So this is it for this video. Thank you for watching.